Okay, this is on the same notes that we drew the two different positioned ellipses. Now we're going to actually be able to find exactly where the foci are and where the vertices are given the equation. On your list of notes, you should have at the bottom what standard form of an ellipse looks like. That's standard form of ellipse on your list of vocabulary. Yeah?
X squared over a squared plus y minus a squared over b squared equals 1.
Good. Okay? Now we've been talking about with circles and with quadratics, if it's within parentheses, like this, H and K are within the grouping. If it's within the grouping, what do we say to ourselves when we graph and write the equations and stuff? Opposite. Yeah, that's a horizontal shift because it has to do with the x. And the x-axis is horizontal, the y-axis is vertical, but we have to say opposite because it's contained within the parentheses, being squared. All right, so in order to see the vertices, we need to have it in standard form. But this equation is not set up like this one is. This equation is equal to 1. So our first step needs to be to get in standard form. Get into standard form. Standard form. Any ideas how to, and we don't even see fractions. Any ideas how to get it equal to 1 and make it into this form?
Square roots.
Not square roots, no. If you take a square root of 36, it's 6. It's, or plus or minus 6, it's not 1. How do we get 36 to be a 1?
We divide it by 1.
We don't divide by 1, we divide by, I heard it back here. Rekha? 36. So we'll divide by 36. That means everything needs to be divided by 36. Okay? And this works out nicely. 4 divided by 36 is not 9. What is it instead? 1/9. Because 4 divided by 4 is 1, x squared. 36 divided by 4 is 9. Okay? 9 over 36. Kevin, what will that simplify to? The 9 over 36. What divides into both? What divides into both 9 and 36? 3 does, but there's a larger one. 6 doesn't work. 9. What's 9 divided by 9? 1. So we'll have y squared. And what's 36 divided by 9? 4. So that would actually be 1/4, right? And 36 divided by 36 is 1. Now it is in standard form. We can see the a squared, we can see the b squared, we can see the 1, and we have our x squares and y squares. Okay? So we need to write the, find the vertices. Let's start with finding the center. If we knew the center, that would help us a little bit. Now the center, remember, comes from the h's and k's, the shiftings. So with this x, what number is being added or subtracted to it? Oops, 0. And we say opposite, which is still 0. What number is being added or subtracted to this y squared? 0. And opposite of that is 0. So the center of our ellipse is 0, 0. Okay, but it's not a circle, so we don't have a constant radius. If it was a circle, we'd say the radius is 1, because we take the square root and it'd just be 1. Okay, so for the vertices, actually let's go back here really quick. What information do we know about vertices? Okay, and on our graphs over here, where did we get the vertices? I think we even labeled them something. On the first graph, we labeled it. It's an extension from the center to the vertices called what? Semi-minor or semi-major, and it has a label. Semi-minor is A, major was A. Semi-minor was B. Okay? So, let's find our A's and B's. We know A squared is what number? 9. So therefore, A has to be 3, because you take the square root. Now, normally when we take the square root of 9, we'd say plus and minus 3, but because we're dealing with a length is positive. It doesn't make sense to say, I am negative 5 feet tall. No, I'd be positive 5 feet tall. That makes sense. Having a negative length doesn't make sense. Okay? What about B squared? B squared is 4. Okay? And if you're wondering where we're getting them from, A squared is the first denominator, B squared is the second denominator. Okay? Fatima, if B squared is 4, what is just B? Good. 2. Okay? So let's draw a little graph that will help us find the vertices and to find the foci. With your ruler, we know it's centered at the origin, so we can do a cross like that. We're going to be using all 4 quadrants. Okay. Let's put the center on. I'm even going to give it a little C, so I remember that point is the center. From the center, we know that the semi-major axis is 3 units long. This is the semi-major axis is 3 units long. So from the center, we need to add 3 and subtract 3, or step to the right 3 and step to the left 3. So where would I have my vertices on the major axis? 3 and negative 3, because if I'm using my semi-minor, it means it's a chord to the left 3 from the center, and to the right 3 from the center. Any questions about those? We get it from that denominator. Take the square root of 9, we get 3, means we have to go left 3 and right 3. And it actually makes sense because this is in the x fraction. The x fraction is the x-axis, okay, your horizontal movement. What about, which axis is this b equals to? Semi-minor. So, from the center, what do we do? Go up 2 and down 2 from the center. Now make it evenly spaced. Kind of evenly spaced. Mine's not a great example. Okay, and once you have those vertices, you can graph your ellipse. And we can now actually list off our vertices. They have points. Because we're supposed to answer what are the vertices. So we have plus and minus 3 comma 0. You could write it like that, or you could write them individually. 3 comma 0, negative 3 comma 0. What's the other vertice? Reverse the order you said the numbers. Because the horizontal shift is 0. And then you go up and down, right? So it'll be 0 comma plus and minus 2. Or you could write them separately, 0 comma 2 and 0 comma negative 2. Okay? Last thing is the foci to find. We've given the foci a name. We know what A and B is. What's foci? C. C. Now, on your notes that we did the other day, I said there's a Pythagorean theorem relation, and it looks a little different than Pythagorean theorem, and I'll draw a reason why. Isn't Pythagorean theorem a squared plus b squared equals c squared? So this looks a little different. So if we have our ellipse, it's kind of awkward shaped. Okay, and we have a foci. This is my major axis. So my foci is somewhere in there. From here to here, it's not the full length of A. I'm going to draw a right triangle. What's this length? It's a semi-minor, yeah? And we call that B, right? So if I connect those, I have a right triangle. Okay, this happens to be the same length as A. So if we did Pythagorean theorem, notice this time my hypotenuse is A. That's why it's a little out of order. The A is just the hypotenuse. So you have to reprogram your brain a little bit. A squared equals B squared plus C squared. Okay, so we're going to find the foci. Find C by using A squared equals B squared plus C squared. Because we know our A and the B, so we should be able to find C, and then we'll know exactly where to plot the foci. Okay, what was A? And we actually have a new A squared, huh? It was 9, it's right there. 9 equals, what was B squared? 4 plus C squared. So we do a little inverse operations, subtract the 4 over. Get 5 equals C squared. Square root. So C is two things, plus and minus root 5, which means we're going to add root 5 from the origin and subtract root 5 from the center of the ellipse, which happens to be the origin. But it has to be on the focal axis. Which axis is the focal axis? The x-axis in this case, because it has to be the wider side. What's the square root of, for graphing purposes, we need to know the decimal. What's the square root of 5? It's approximately like 2.7, is it? 2.2? Okay, 2.2. So from the origin, we need to go to the right 2.2, and I'm going to label it root 5. And 2, this is one of them, F1. And from the origin, I go to the left 2.2. I'm going to label it negative root 5. And that's F2. That's how we find our foci. Okay, so the points would be plus and minus root 5, comma 0. Okay, we're not going to send you off with any homework on this over the break. There's the bell anyway. We'll pick it up when we come back. Have a great break. Remember, all late work is due tomorrow. We have operational fail today. Yes, we do. It'll be in Miss McDonald's room 121. Just put a pile of rulers at the end of your desk and your pencils at the end of your desk.